The veins are the vessels that return blood to the heart, and they function as capacitance vessels. So the reason that they are called capacitance vessels is because that at any given moment they contain most of the body's blood. Veins tend to have larger lumens than arteries do, and recall that larger diameter lumens give very little resistance to blood flow, and therefore veins allow blood to flow very easily through them. Veins also tend to experience much lower blood pressures than arteries do. So at any given moment, approximately 60% of the body's blood volume is contained within the veins. The walls of the veins are much thinner than the walls of the arteries because venous blood pressure is much lower than arterial blood pressure. Veins, as a result, have two adaptations for dealing with low blood pressures. The first is that they have large diameter lumens, which offers very low resistance to blood flow. The second adaptation is that they contain valves that prevent backflow of blood. These venous valves resemble the semilunar valves that are found between the ventricles and the aorta or the pulmonary trunk. These valves are most abundant in the veins within the limbs. Varicose veins are a type of vein that is dilated and they have leaky or incompetent valves. Varicose veins can be quite painful and they are a result of prolonged standing or obesity. And this, in particular, in cases of prolonged standing, this causes blood to pool in the limbs and weaken the valves over time. We also see that varicose veins can occur in the anal region. These are anal varicose veins, also referred to as hemorrhoids, and they are caused by straining when delivering bowel movements. This straining creates high pressures within the veins and weakens the valves. So let's examine three types of veins. We see there are venules, veins, and venous sinuses. The venules are small diameter veins that leave capillary beds. They're draining the blood from capillary beds to the veins. Postcapillary venules are extremely porous and allow fluid and leukocytes or white blood cells to move across them. The postcapillary venules are often very common sites of inflammation during infection or during inflammatory responses. We see here in this diagram that veins come in two varieties. We have small veins, which have small diameter lumens, and large veins, which have larger diameter lumens. The large veins tend to be in closer proximity to the heart than the small diameter veins are. And finally, we have venous sinuses, which are specialized flattened veins that have thin walls. Veins like the coronary sinus and the dural venous sinuses that surround the brain are two examples of venous sinuses. So one such example of a dural venous sinus we saw when we were examining the structures surrounding the brain, and one of those dural venous sinuses was called the superior sagittal sinus. This sinus drains blood from the blood vessels on the surface of the brain, and it also serves as a site where cerebrospinal fluid can drain from the subarachnoid space. So we see that the tunics of both venules and veins are composed primarily of collagen fibers and smooth muscle. The smooth muscle of the venules and the veins allows these vessels to change their diameter, and therefore that controls both blood pressure and direction of blood flow. The collagen connective tissue helps the veins to hold their shape, but does not allow for much stretching. So notice that the veins have very little, if any, elastic connective tissue in them. Large veins tend to have some elastic connective tissue, while venules are absent of elastic connective tissue. We also find that there's a lot of redundancy in the connections between blood vessels, and this acts as a safeguard to ensure that blood flow will always continue along an alternate pathway in the event that a blood vessel is blocked or cut. And these alternate routes are called anastomoses. Arterial anastomoses are arterial branches that provide alternative pathways of arterial blood flow to an organ if one of those arterial branches is cut or blocked. Arterial anastomoses are common in joints, in the abdominal organs surrounding the brain, and in the coronary circulation of the heart. Arteriovenous anastomoses are examples of anastomoses that allow shunting or bypassing of capillary beds. Here we see that arteries connect directly with veins. And finally, we will examine the venous anastomoses. These are common in veins, as veins tend to branch and merge together quite commonly in the body. Simply examining the back of your hand, we see the extensive merging and branching of the veins that are located there. So as a result of these extensive venous anastomoses, if a vein is blocked, it rarely, if ever, causes any interruptions to blood flow.